Assalamualaikum everyone, welcome back to another video of CSE 220, and today we'll be doing sorting, which is a pretty boring thing to do but interesting if you can do it yourself. So sorting, there are many types of sorting. Don't get the idea that there are only three types of sorting, which are known as bubble, selection and insertion. These are only three. There are many types of sorting, not to mention you can create your own custom sorting method or algorithm, whatever you say. So there are many ways to sort, but today as for CSE 220, as far as CSE 220 is concerned, we'll be dealing with selection and insertion sort. There are many other sorts. You'll be doing that on 221 inshallah. That would be another series, another thing. So for 220 we'll be doing these two. As you can see over here, we're skipping bubble, but you can read it up. Yeah, thank you, I don't need to, because the possibility of coming up this thing is very low. But if you still need a code of bubble sort, I will upload it for you, just so that you can see how it works. So that's for bubble sort. Please check, don't forget to check the link. You'll find the bubble sort there. I will try to remember to upload this. So let's move on to selection sort. So what exactly is selection sort? Selection sort is kinda like, let me tell you, for example, take these numbers. So you will find, let's go, I'll show you. Let's get to reading. The idea is very simple. We select the minimum element in the sequence and move it to the first position, and then select the minimum element. Oh man, so boring. So you will pick this number, and then if it's the smallest one, then it's on the left, and if it's the biggest one, then you move it to the second position. I'll show you a sample. Have a look over here. So we have 17, right? And the minimum is 2. Let's exchange it with 17. So where do you find 2? Over here, 2. So 17 has moved to 2's position, and 2 has moved to 17's position. Huh? Very interesting. Now let's go for 3. Okay, 3. Now 3 is the minimum among all, so there is no exchange. Oh, come on. So there's no exchange. Now let's look at this. 9. Is there any number who's less than 9? Yeah, there's 7, there's 5, but 7 is not my concern since there's 5. So I'll bring 5 and I'll send 7 there, 9 there. Now we'll look for 21. Of course, there's 17, there's 7, there's 9, but the smallest one is 7, so I will move 7 over here. And then for 17, there's 9, so I'll move 9 over here. And then 21 and 17, there's 17, and then 21, and it stops. If you want to recap, I'll do it. You have this series, and you pick the first number, and you check if all the other numbers, is there any one smaller than this? Yes, there is, 2. So that's why 2 is over here. Then you take the second number, 3, and then do the same thing, but there's no one smaller than 3, so 3 stays. And then you pick the third number, 9, and you find 5 is smaller, so you send 9 to 5 and 5 to 9. That's how it is. 2, 3, 5, and there's 9. And you then compare 21, you find 7, and then 7 shows up. In the same way 9 shows up, and then 17, and then 21, and then you stop. That's how you do selection sort. It's as simple as it sounds, and the coding is not so complicated as well. Here, I'll show you. If you don't, let's go step by step. So first of all, of course, we will receive the array, otherwise you're not gonna sort your what are you gonna sort if you don't have the array? So you can take a while loop, you can take a for loop as you wish. Data dot length for the full length of the array, and -1, you know what that's for, that's 111 stuff. So you need to find the index of the minimum item starting with at I. So take a mean index or name whatever you want and keep it I, and for under this loop take another loop and check, which will start from I plus 1. I is 0 over here, so it will start from I plus 1, and it will compare all the elements. And now this sorting can also work for strings, okay, sometimes. So, and this comparable class is used and the comparison is done, and then you'll find your minimum index which you're looking for. So if we were looking for 2 or 3, then we'll find this 2, and this 2 will be at this minimum index. But that's not the only task I have. I need to put it in the position I have right now. I have to exchange myself. Remember that 2 will come here and 17 will go there to 2's position. If it is like this now, something, then I'll have to put 2 over here and 17 over there. How do I do that? This is the part that I do for the exchanging. So if I is not equal to minimum index, I take an object temporary and put the data there, and then I put the position. Since this is an array, it's no big deal. If it was a linked list, we would have to run a marathon or something to do this, but since this is an array, we can just exchange the indexes. So we put that array, hey, come on. So we put that array and then we exchange the positions. Simple as that. So that's how you do selection sort. Very simple. Just pick a number and then find if there are any numbers which is smaller than that. If there is a smaller one, then put him and exchange with this, and keep exchanging until all the numbers are exchanged. That's selection sort for you. Easy. Now we'll move on to a new type of sort, and of course this is a sort for the linked list. As you can see, a lot of work over here, but the idea is the same, absolutely the same. Here this is the exchange part, as you can see, taking an object, swapping the values, and then there's the loops that we need to do, all those things. Okay, insertion sort. Now this is a little bit tricky for some people, but then again there are people who understand it very easily. So let's try the luck. So insertion sort is kind of similar to them, but here it will just keep comparing the numbers at the right side of you. Let's look at the reading. Insertion sort also works by partitioning the array into sorted and being processed parts, but works very differently than selection sort. At each step it takes the next key in the array and moves it left until it's in the rightful place, and moves the partition one step to the right until the whole array is sorted. Since an one element array is sorted, we start moving the element in index 1. So if you have the same thing which we used in the sorted index, what's the difference? The difference is, if you take one value for this, it will just keep changing the positions. For example, you have 3 over here, right, which is definitely smaller than 17. So 3 is moved, 17 goes forward. Okay, I find 9, that is also smaller. Put 9 in your position. Here, look at this. 9 is also smaller, so remove him. Okay, now I move forward. 21. Yeah, 21 is bigger than me though, so I'm not gonna move 21 for now. So let's keep him. Okay, 21. And then 2. Hey, hold on a second. 2 is smaller, way much smaller. Put 2 in the right place at the beginning, and then move forward. 7. Okay, this is not for the first place, it's between 3 and 9. Let's put it there. So put 7 in between 3 and 9, and then 5, put it between 3 and 7. Done. That's how you do it. So at each step we essentially insert what kind of English is this? We insert the key, and by scanning the whole thing we move the positions. For example, the point you note here, 17 was moving, and when we reach 21, since it's bigger, we didn't move 21 to the left, but we did move 2 to the left. So the smaller ones are going to the left and the bigger ones are staying on the right side. That's how you sort this. That's the idea. So how does the code work? Let's see. First, simply same as sequential sort, or selection sort, sorry. So you take the I and you start the for loop, okay, and then you have this object key, which is the one you're going to start this partition with, and then you take a j which is less than I to start scanning, and you can use a while loop for this, and if you find it smaller, then shift it to the left, or you can just do the what they did over here, that if there is a smaller item, we shift the item we have, and then that's just how 17 moves right works, right? So if it was 17 to 217, 217, that's what it becomes, this rightward shift of 17. That's what they did. Shift item right to make room. There are comments of every single step what they did, so it's very useful, this all notes. It saves us a lot of time, and I'm not doing this like the previous ones, because probably you won't be having these sortings in your exam. You'll be having different kinds of sorting, or you may not even have a sorting. So when you find the position, you just put it as the key, and that's the idea of sort. So the difference, let's go through the differences again. So when it was selection sort, you just have to compare the numbers and then move each of them, exchange them. Not moving, you exchange them. So when it was 3 and it was 21, I exchanged the position until they're sorted. There is no exchanging on insertion sort. These are the numbers moving. If they're smaller, go to the left. If they're bigger, remain on the right. That's the idea of insertion sort, and this is the same for the linked list as well. So you can apply this on linked list, even though they didn't show it, but you can do this on linked list too. You can just Google it, but they won't give you that. Since it's not over here, it will not be given to you. So guys, that's all for sorting. Once again, these are light topics, that's why I didn't spend much time on this. All you have to do is understand how they work. Now you know how selection works, and now you know how insertion works. Selection, just check if they're smaller, exchange the positions. If it's bigger, then okay, it's fine, and it moves until it's sorted. And for insertion, you keep moving the number, the key, the inserted value, and you change the positions. If they're smaller, move it to the left. If they're bigger, keep them on the right. That's how, until the cursor you use reaches the final position properly, you keep doing this. That's how it's done. So that's all for sorting, and inshallah in next class we're going to start a big thing which is called recursion, probably. So that is a crucial topic for this course. Until then, see ya. Keep surviving, guys. All you need to do is survive.